Lab 6 of EE542 Machine Learning and Deep Learning. Team members are Veda Shyam Kadam and Sukruth Lokesh Babu. What is machine learning? It is a method of data analysis which automates analytical model building. Basically, you give data to a model and it gets trained and evaluates any further data given and gives predictions on it. Deep learning is a part or a broader family of machine learning methods, but it is based on artificial neural networks. It has an input layer, many hidden layers, and output layer. This is a branch of artificial intelligence based on the idea that systems can learn from data, identify patterns, and make decisions with minimal human intervention. The main difference between deep learning and machine learning is the artificial neural networks. Machine learning depend on algorithms, whereas deep learning depends on the hidden neural networks. Machine learning almost requires structured data, whereas deep learning are totally based on ANN. Here we have plotted scatter plots for all the different features in our data set such as skewness, kurtosis, entropy and variance, and we have plotted it for all permutation possible. Machine learning using AWS SageMaker. Here the steps involved are fetching data and making it in a suitable format. As we saw that machine learning almost requires structured data. The formatted data is given to machine learning algorithms. In AWS SageMaker provides many machine learning algorithms as software and suitable hardware to run these algorithms like high standard GPUs. Once the ML model is trained with the training data, we give test data to see its prediction and evaluate it.
Now I'm going to explain the part 1 of lab 6. So here we are given a banknote authentication dataset. It has 1372 instances as we can see, and each of them have 4 features: skewness, kurtosis, entropy and variance, and they have one label, whether it's forged or genuine. So if it's genuine, we have it as class 0. If it is forged, we have it as class 1. So we can choose any one of the algorithms and build a machine learning model. So for our test data, for our train data, we select the test data and the train data. The test data is first 200 rows of class 0 and first 200 rows of class 1, and the training set is the remaining out of 1372, that is 1372 minus 400. And we have been given the dataset over here at this link. So let's see how to do this using Amazon SageMaker. So we have followed these steps which are given in this particular tutorial to do our lab. So first we need to create Amazon SageMaker. So these are the steps which we followed in that tutorial. So we went to Amazon console and we got we typed SageMaker, then we went into SageMaker and we created a notebook instance. And after creating the notebook instance, we gave the name for our notebook and we created a new IAM role as we can see over here. And after that, we gave any S3 bucket. Then we got our notebook instance. So we can see that over here that we have got our own notebook instance lab 6, and we can see that it is in service as well. So next we went ahead and followed the following steps. So first we needed to import few of the libraries to implement this tutorial. So we did this over here. We imported libraries and we have defined containers here as well. Then after that, we were asked to do the scatter plot of different permutations of skewness, kurtosis, entropy and variance, and we have achieved it over here. And for that purpose, we defined a plot scatter function. We have implemented the code here and used different features 2 at a time. So as we can see, skewness, kurtosis, skewness, entropy, etc. Each of the features have been assigned a particular color as we can see here. So when we ran this, this is what we got. we got the six different set of scatter plots. So we can see this over here. So there are six of these scatter plots, and from this we can see that the variance which we got was highest for skewness. So skewness is the most important feature which we have. So using skewness we can train our model better. That's what we understood using these scatter plots. Then after that we needed to create a bucket wherein we could store our banknote authentication data set. So that is done over here, and we can see that the S3 bucket was created successfully. Then after that we needed to retrieve the data from this particular URL. So we used the URL retrieve function, and we have stored it in data banknote authentication.txt. Then we loaded it into a pandas data frame called model data. So both of these tasks were successful, as we can see over here. Then after that we needed to separate the test data and the train set data. That is done over here. So we have taken with class 0 the first 200 of them, and with class 1 the first 200 of them, and we have created the test data here by concatenating them. That is data 0 200, data 1 200, and we have created the train data, which is the remaining number of sets in that 1372, excluding the 400 which we allocated as test data. Then after that we needed to draw after that we needed to use Amazon SageMaker pre-built XGBoost model. For that we needed to reformat the header and the first column of the training data and load the data from the S3 bucket. That we have done it over here, as we can see. Then we needed to set up an Amazon SageMaker session and create an instance of XGBoost model, that is an estimator, and define the model's hyperparameters, which we can see right here. And we ran this particular set of code which was given in the tutorial. Then after that we started training our model using the train dataset, and as we can see the training started, and we started the training job, launched requested ML instances and prepared the instances for training, and we downloaded the input data, and the training took place, and we uploaded the generated training model, and the training job was completed, and the billable seconds was 64. Then we started making our predictions. So this was done using gradient descent optimizer, and as we can see here, it's given right here. So to deploy the model on a server, we needed to create an endpoint in an Amazon SageMaker, and therefore we copied the following code over here, and we created an endpoint and deployed our model, which was trained over there at the particular endpoint. Then after that, to predict whether the customers in the test data were, not the customers, the banknotes were forged or genuine, we used the test data which we had collected before, that is 400 values, and we passed them through this model and started predicting it. And after that we created a confusion matrix to see how much of it how much were our predictions correct, and we achieved overall classification rate as 99.8%. And further we had been asked right over here to determine the training accuracy, test accuracy, and test F1 score. So the test accuracy was 1, and we can see the F1 score was 1 as well. So, and the training accuracy was 1 as well. So therefore we were able to deploy this model, and we can see that our model has been, this was the S3 bucket which we used, which had our data, and we can see this right here. This was our training data, and this is our Amazon SageMaker, and as we can see we have created two models which I was testing, and I have used one of them right here.
Deep learning using AWS EC2. The steps for deep learning are almost the same as machine learning, except that here we have to create our own model using neural networks. First, we fetch the data and make it into a suitable format. Then we create a neural network model. Here we give one input layer, one hidden layer, and output layer. You can give as many hidden layer as possible until you get a suitable output. The formatted data is given as input to the custom model. AWS provides GPUs to run these extensive computations of neural network. Once the model is trained with training data, as we did it in machine learning, we give the test data to its prediction and evaluate it. After making an instance, we will go into the folder where we have downloaded our security file. Here my security key is AWS Educate Deep Learning AMI. I will change its mode by giving chmod, and then I will connect it using SSH. Here you can see I've included my security key, and this is the DNS IPv4 from our instance, as you can see. Now I connect it using SSH, and now I've connected to my instance, which is an Ubuntu. Now we just type the command Jupyter Notebook. After this command gets executed, we'll get a runnable link which we can copy in our browser and open Jupyter Notebook. This is our link and we copy it. We go to our browser and paste it. This should open our Jupyter Notebook, and as you can see, this is our Jupyter Notebook. This is our deep learning .py file, and here we have encoded all our code. This is the deep learning part of the lab. Here we have imported libraries such as TensorFlow, Keras, NumPy, Pandas, and we have also imported other libraries from sklearn and OS. We can print the TensorFlow version and make sure that the eager execution is true. Now we will download the dataset from the given UCI archive, that is data underscore banknote underscore authentication. We load it into a variable called model underscore data as a pandas data frame, and when you print it, you can see that we have kept the class as the index and other terms as the columns. That's why it shows 1372 rows into 4 columns. Here we printed the first 200 data, and you can see that all of them have index as class of 0, 200 into 4 columns. Now we will modify our data so that we can give it as training and test. We take the we make variables for train set with class 1, class 0, and rest set with class 0 and class 1. We take the first 200 of class 0 and club it with first 200 of class 1, which is from 762 to 962. We make sure that the index is fall, that is dropping the class, and we do the same for train set. And here you can see that there are 400 rows and to 4 columns, and we have our test data. We do the same with train data, and we put them both into an array called train data array and test data array. Now we make another array of zeros using numpy, and we know that out of the 400 test cases only 200 are 1, so we made sure that the later 200 are 1. Similar, we do that for training set, and we have printed the training set, and as you can see the end ones are 1. Here, let me remove the old part. Here we are making our model. Our model has 3 layers: input layer, hidden layer, and output. One hidden layer and output layer. The input layer has 4 input. The hidden layer also has 4 inputs, and the output layer has 1 input with sigmoid as activation. Then we compile our model using loss as binary, cross entropy, optimizer as Adam, and metrics as accuracy. Then we fit our data. Here we pass our training data array and its actual value, which is stored, the class value which is stored in data underscore train. This time we had got an accuracy of 92.18%. It changes every time. Then we give it to evaluation by passing test data as input, and we got an accuracy of 99.75%. And using F1 score function, we also printed the F1 score, which is 0.997506.